Good afternoon, everyone, and thank you for coming to my talk. Today, I'll talk to you about the role of Python enhancement proposals and how they help Python evolve throughout the years. So before I begin, a few things about myself. I'm Nikos Angouras. I'm a software developer and an electronic engineer, and I currently work as a research and development software engineer in Public Next here in Athens. So let's begin. So in this talk, I'll go over what exactly are these Python enhancement proposals and why they matter to, and they should matter to us as a community. The life cycle of a given proposal, what it goes through, as well as some historical examples about some important PEPs of the past and some things we're coming from those. Lastly, I'll go over how the community, each and every single one of us, can participate in this process and build a better Python for the future. So what exactly are these Python enhancement proposals? Essentially, each proposal is a document. So when someone comes up with a great new idea for Python or some feature or something they want to add to the language, they need to convince everyone else that it is actually a good idea and it is useful. So they come up with a design document that they then submit for review to the members of Python, and this is then used to as a basis to build upon Python and improve it. Also, something very useful about these proposals is that they are logged and cataloged. So there's always a clear history of how Python came to be what it is today. And it's very interesting actually to go over some of them yourself and look into them. So these proposals can be categorized into three main types. First of all, is the standard proposals, which describe some new feature in the language or improve upon an existing one. Then there's the process track, which has to do with proposals that have to do with the processes surrounding Python. For example, PEP 1 is the one that has to do with what exactly describes what PEPs are and the guidelines for creating these documents. And then there's the informational types of PEPs, which is essentially used to communicate some information to the Python community. For example, PEP 0 is an index of every single PEP there is. Then if you want to find a PEP, you usually go through PEP 0 and you can find a list of them. So let's go over the life cycle of a proposal. But before we do, I'd like to go over some of the key players when it comes to such a proposal. So it all starts from an idea that someone has, maybe a cool new feature or something that they want to change about Python. And it has to be some kind of major change that they want to propose. This person, also named the PEP champion sometimes, is the one who proposes this change and is responsible for this document throughout its life cycle, for gathering feedback, improving upon it, and going through it from start to finish. Also, once someone has an idea, they also need to get someone to champion their proposal. So they usually have to sponsor, the proposal. So they usually have to pitch the proposal to a core member of the Python community, and they would have to sponsor this idea so that it can move forward. There's also the steering council. So this council didn't exist until 2018. Up until 2018, the creator of Python, Guido, was the one who had the final say in accepting or declining any new changes to the language. Until 2018, when he stepped down as benevolent dictator for life, as they called him. So he had the one who had the final absolute say for the language. But in 2018, he stepped down and a council was created instead, which is called the Steering Council. This council is comprised of 5 members which are voted democratically from the Python core team members or the core developers. Also, sometimes this steering council might appoint a delegate for a specific PEP. So someone who's usually an expert in the field and can help with the process of the proposal and give feedback to the champion of the proposal. Lastly, there's the community. That's all of us who can participate in. So Python is an open source language, so the community is welcome to participate and provide feedback and go through this process along with every one of these core developers. So what does the timeline of a proposal such as this one look like? So as I said earlier, first it starts with an idea that is usually discussed in some kind of Python mailing list or a forum, and this is sponsored by a core developer. Once this idea is sponsored, the champion of the idea has to come up with a draft, a document pretty much, that has strict guidelines, and this has to be accepted by some editors of Python. Once the proposal is accepted, then it's put up for review. So this can be a long process. It can take a few months, it can take a few years, but there's a lot of back and forth, lots of iterations, lots of revision cycles to make sure that the proposal is actually in a good spot and it's actually an improvement for Python. So once everything is done with this revision cycle, we move on to the final decision. This is done by either a member of the council or the delegate. And if the proposal is accepted, it's implemented into the Python code base. So let's go over a historical example. That would be PEP 484, which has to do with type hints. So for anyone that may not be familiar with type hints are a way to essentially make sure that the input and output of a function is of a specific type, for example, integer. So Python is a dynamic language, and functions can accept any type of input or output. And this is definitely a blessing, but in large code bases can be a big hindrance in maintaining clear and readable code. As an example, I have a very simple function here that adds two numbers together. So at the top, you can see it add two numbers without type hints, and at the bottom there's type hints for every input variable x and y, which would be an integer, and as well as the return value, which is also defined to be an integer. So what this does is it allows an IDE, for example, to catch inconsistencies in the code or early bugs before the final product is shipped, and this allows for much better and better flow in development. Also, a very important part of this proposal is that it's backwards compatible. So it's optional, and it doesn't break all the existing code that exists everywhere that doesn't have type hints, which means that it was able to be accepted and implemented gradually moving forward. So what exactly makes a successful proposal? First of all, and most importantly, it needs to address a clear and distinct problem. So this idea needs to be thoroughly researched, and the champion of the proposal needs to be able to gather any feedback that they receive and put it back into the proposal to improve it. And most importantly for Python, because it's such an open source project, it needs to have the support of the community. So any proposal that might not have the support of the community, no matter how good it is, in theory, it's probably not going to get implemented. Lastly, other than, of course, the quality of the proposal that is to be good, it has to adhere to Python values. For example, a quote by Tim Peters that I really enjoyed is that beautiful is better than ugly, and simple is better than complex. And this definitely shows when reading Python code that you can always, it's compared to other languages, at least for me, it's much easier to read and understand it at the first glance. But of course, when it comes to a language people use, a lot of people are gonna have a lot of varying opinions on what is good for a language and what isn't. An example of that caused a lot of controversy would be PEP 572, which is a PEP that introduced the walrus operator. So that walrus operator is this little symbol of the dots with the equal sign. And I guess if you tilt it sideways, it looks like a walrus somehow. The equals would be the teeth. And that's why it's called like that. So what this does is it allows you to assign values to variables in places that normally one couldn't in Python. And this was a very controversial change because a lot of people felt that it was un-Pythonic in nature. It made the code less clear and more confusing. And but a lot of people also thought that this was a very useful tool, and it wasn't a tool used often, but when you did, it was very useful to have. So what happened at the end of this proposal is that Guido, who was still the benevolent dictator of all at the time, he decided to accept this proposal. And when he did, the community was erupted in a way. There was a lot of negative feedback towards him. And I think it went to extremes even. So resulting from that, he decided to step down from his position to have and no longer have the final say in all these processes. And that's how the council was created. All right, so I also want to go some other historical PEPs that I found to be very interesting. The first one would be PEP 8, which has to do with coding style. This is a core feature of Python, and it has to do with certain rules or directions to follow when writing Python code. For example, this includes indentation or spacing between and after functions, perhaps how you would name a function, for example, using lowercase letters instead of capitalized, etc. Then there's also PEP 257, which has to do with documentation. So this PEP is the one that introduces docstrings to the language. Docstrings, for anyone who may be unfamiliar, are a way to describe what a function does within that function. So it's essentially a block of text at the beginning of the function that describes what it does. This, for me, is very important, especially for being able to understand what your code does, for example, 6 months or a year after you write it, because that's usually a nightmare for most developers. Then there's PEP 498, which is a favorite of mine. It has to do with the F string. The F string is, I have an example here in the middle that's a bit cut off, but should be still visible. It's being able to add a variable inside a string. So I believe in the past you would have to write a string, then print the variable, and then print the rest of the string. And now you can imbue it inside a string. Then there's PEP 492, which introduces a lot of important asynchronous syntax in Python, such as the async and the awaits in coroutines, which were definitely needed at the time and for Python moving forward. Lastly, I want to go over PEP 8016, which is actually the PEP that, so when Guido stepped down in 2018, the members of the Python community needed to decide how to move forward and who was going to replace him. So what they did is they came up with PEPs. Everyone submitted a lot of proposals, and the one that eventually won was the one that created the steering council. All right, so we went over the historical context of a lot of these proposals and how they helped build essentially the Python that we all use today, or at least most of us probably do. So if anyone wants to participate in this process, it's of course an open community that welcomes everyone to participate. There's a lot of resources that one can use, such as for example, going through to the Python website and reading through existing proposals that were accepted, or there's also in PEP 1, there's the general guidelines of PEPs that are very interesting to read. And there's a Python developer's guide that I would highly recommend that has a lot of useful tips for Python developers. Also, you can sign up to the Python Ideas mailing list to discuss new and up-and-coming ideas for Python, and participate in the forums where there's a lot of discussion to be had as well. Lastly, there's, of course, you can engage with the local community, such as everyone here today. And if anyone wants to be a core Python developer, there's a mentorship program that helps someone go through that process. Lastly, I wanted to say that every feature that we now have in Python, it wasn't randomly selected or randomly chosen for no reason. Everything has a clear reason that it is the way it is. And it all comes back to an idea that someone had. So I would encourage everyone to, if they have a good idea for Python or anything along those lines, to be brave enough to share that idea, to gain feedback on that, and help build a better Python for the future. Thank you very much.